Hello, everyone. Super glad to be here one more time in Sofia. So it's a lovely place to stay. It's my third time. I enjoy a lot this conference, especially the weather. And trust me, I come from Brazil, so I love sun and I hate raining a lot. I I have the dream of the snow. I had never seen snow before, but every time that I talk with someone from Sofia, they start to complain about me. Are you crazy? Everybody hates snow. But for somebody that never seen that, it sounds like an amazing idea. So I'm glad to be here again. I usually talk more about software design. Right now, I will put a higher level on discussion. Right now, I will discuss more about software architecture and mainly how to apply domain-driven design over 100,000 engineers, right? I guess everybody here have heard at least once about domain-driven design, right? So please raise your hand if you have heard about domain-driven design. Whoa. Okay, now keep your hands up. And if, only if, you have seen it using properly on side organization. So usually, oh, just one person. The hero. Probably, yes. It's a startup just with him. So with one person might be easier. So anyway, thank you. The issue is how to apply that on reality. And I have facing that a lot, a lot. I have been in Brazil. I hopefully have a good case applying that with over 20,000 engineers in Brazil. It's a huge Latin America bank right now. It is the biggest one in Latin America. And my goal is to explain the step by step how we could apply. I don't dare to say properly, but fair enough, considering that I need to handle with over 20,000 engineers, right? So before I start, it's important to give the context and the reason why everybody is talking about agile domain-driven design and why it's super hard to take that in action, right? So we could see in the history of software how it's going to increase in terms of influence. Right now, it's almost impossible to think any kind of business if without thinking about software. So we could see on 2011 about Forbes when he said now every company is a software company. So right now it's impossible to be a company if without doing software. Then we moved to 2018 where CEO Network complains about now every company is a data company. And finally, with COVID, it was not about agile codes. It was not about Scrum Master. The COVID make it faster. And CMMI said that right now every business is a software business. So doesn't matter what you're gonna do. You probably might gonna use software. But we know that is important, right? We know that you need to make the deal with the client, to achieve the goal with the clients. However, every year we can see in Forbes the reports about results on inside soft development, and usually the report shows 16 obstacles to don't have success inside the project. I dare to summarize those in 4 categories, where we usually start with doing a lot of designing, planning, discussions, let's put microservices here, and so on, so on. And for some random reason, we forget what the client wants. So that links to the next one, where we don't have a clear or defined client expectation. So we spend a lot of time discussing what the client does not want. You'd be like, we are going to the pizza restaurant, order a pizza, wait for 8 hours, and then receive a salad for $200. So I need to pay super expensive value to one thing that I don't want to. How about that? So basically, that's how we are leading with software development nowadays. So it sounds like a cliche that you need to achieve what the client needs, but in reality, we are not getting even close. And the consequence is we have a poor collaboration between product and engineering teams. So we have no idea about what they want. And the reason is sometimes we spend a lot of time discussing technology. So right now we are living in two amazing paradoxes. The first one is the paradox of choice. As much choice we have, more difficult it's become. And trust me, it's happened at my home every single day. So right now I have 4 different streamings. So I have Netflix, Disney Plus, I have Amazon Prime, and the fourth one I have HBO. And sometimes I spend 30 minutes to choose the movie, and I fall asleep after 5 minutes. So I spend way more time selecting the movie or series than watching what I need to do. And that's exactly what happened with technology right now. We are leading with a huge amount of technologies, a huge amount of patterns. And sometimes it's become harder, not because the tool is not amazing. The tool is amazing, but remember, when you talk about software architecture, the right patterns in the wrong context become an anti-partner, right? So microservice is amazing, right? But imagine I put a microservice in a startup with a single person. So it might be an over-engineer, or I have 10 engineers to over 100 microservices. So right now we have one engineer leading with 10 microservices. So it sounds like an over-engineer or overkill. So that's the point of paradox of choice. So we have a huge amount of choice, and sometimes because we have a huge amount of choice, we spend a lot of time, and eventually we go to the hype, right? Because the hype is a safe way to handle things. And naturally, the article shows it's become more complex, and this complexity is killing software developers, mainly in the market. Especially because sometimes we don't discuss software architecture. So every decision that you take when you talk about software architecture has trade-offs, right? So our advantage and advantage of using microservice, monolith, distributed system, event-driven design, and so on. Sometimes we don't spend time looking for it. And okay, right now we know that we are not even close for agile, right? So we are not delivering what I need to deliver. We could see Forbes reports about we spend a lot of time doing planning, but that's not the client doing what the client does not want to. And yes, unfortunately, it could be worse. I promise if there is more 2 slides, you don't need to cry about your career right now. So this article here, sorry, this book here comes from Kent Beck, the creator of XP. So the guy from also Agile methodology. And this book, he explains about what is the most expensive type in a software project. The component that's more expensive inside any product nowadays, following this book, is the capability of keeping evolving, the capability of being evolutionary, and mainly the capability of change if without breaking anything. So we have spent a lot of time discussing some over-engineered architecture, and we are forgetting to test, to guarantee the current behavior, to make safer to do refactoring, and so on. And finally, real world, right? Sometimes the code decreases the quality. That's reality. Nobody writes a perfect code. And if this person does, eventually the business will change a lot of things. So the decrease of quality of the code in any soft product is a reality. Doesn't matter. The code they're doing eventually will become with not good quality as well. So you can take, for example, this book here, Building Evolutionary Architecture, that explains more about the software route, where how to handle with the decrease of quality. Okay, and okay, I show a lot of points around software architecture, soft design decisions, and the client expectation. And the first thing that come out of my mind is, are we really doing software engineering? Because in general, at all, we are wasting time in meetings, right? We are doing a lot of meetings, but we are discussing one thing that the client does not want to. We are creating complexity that is not ready for change. And guess what? The life changed. We changed, but not our code. And the consequence is we are doing legacy code, super premature. So I have been working in finance, and one thing that I learned from finance is if you need to rewrite the whole code with less than 10 years, for us in finance is a premature legacy. So the code should stay for at least 20, 30 years until redesigned to something else. At least that's my reality. So rewrite a whole code after 2 years for us is a premature legacy. And especially, we are not achieving the client goals. So we are kind of lost right now. And the question stays. So we are super inefficient the way they are building software right now, unfortunately. And I know there is a huge amount of definition around software design. My favorite one is not a academic. It belongs to David Foley that mentioned that software engineering is the application of an empirical scientific approach to find efficient economic solution to practice problems in software. So we need to solve something to define ourselves as software engineer. And that's supposed to be solved with Agile, right? So Agile was born in 2001, if I'm not mistaken, the year. But 2 years ago, they show a report about how Agile is going. And they got a conclusion of the Agile is that, long life to agility. So nobody is using Agile as the way they're supposed to be because it's not efficient. So probably you have tried using Scrum, and eventually it's become a waterfall of 2 weeks. I guess everybody did that. I surfed that every single time. And the reality is, if you are having succeed with Agile, you are an exception. So 31% of the Agile projects are considered successful. So if you are using Agile right now and having success, congratulations. You are an exception in the market of software industry. And he comes with the way to solve that, as I mentioned, the way that everybody already knows, the domain-driven design. So it was born right after the Agile methodology, the Agile manifesto, where the goal is naturally we want to get closer to the client to meet the client expectations. The domain-driven design, that I wrote wrong, by the way, so I should have tested, is about delivering what the client is or what the client wants to. Where domain, you can understand as knowledge. So it's the knowledge of the client that you take from the domain experts, the person who knows the business, and then convert to a software. So I talk about how important domain-driven design is, but let's start explaining what is not domain-driven design. Because I guess everybody has your own definition about domain-driven design. But let's clarify it a little bit. Domain-driven design is not about framework. Otavio, I'm using Spring, so I'm using the repository interface. Thus, I'm using domain-driven design. No. It's not about using repository in Spring. It's not about using Java. It's not about using microservice. Indeed, if you are talking about domain-driven design and you are only discuss about code, you are not using domain-driven design. That's the reality. And another point is the complexity. So sometimes we link domain-driven design with complexity, and that's not true. The goal of domain-driven design is to transfer the knowledge to the software. It's not about the pattern that we're going to use. It's not about using microservice and so on. So with that definition, let's discuss more about what is really domain-driven design. So the main goal, as I said, is transfer knowledge. So we have the domain, the knowledge of the organization, where we're going to transfer as software. And we have two types of domain-driven design, or two layers. One is the strategic one, using the strategy, where you're going to understand the context, apply the rules, define the ubiquitous language, define the mapping, the context, and finally, after know everything about the strategic, you can go to the tactic, not the opposite. So, as I said, domain-driven design is not only about code. It's about getting knowledge to a software. It's starting with the strategic, the most big mistake when people try to implement domain-driven design. So the first step to implement correctly about domain-driven design is to understand the domain of your organization and your subdomain. Understand the context mapping of your organization. And based on that, you can define the terminology or ubiquitous language. And finally, define the context. And Otavio, why do I need to use the same terminology of my domain expert? The reason is you need to communicate between, you need to transfer knowledge. So the first step, naturally, is to understand the domain. Given that, it's important to know that domains contains subtypes. Usually the most important topic inside domain. And naturally, if I need to put priority and task, I will going for the core subdomain. Then we have the generic, that is important, but not that important like the core. So it's going to help me to define my domain or to define my core domain and my supporting subdomain. So it usually doesn't have a medium differentiation, and the complexity may vary. For example, if I'm running an e-commerce, my core of domain is to selling products. My payment is more a generic subdomain. So I can use, for example, instead of implement my own payment provider, I can use a third party, PayPal, Stripe, and so on. And my supporting might be sending emails about notification on the product. So e-commerce, selling, generic payment provider, and supporting message. However, if I work in a payment provider, the payment provider becomes, so the payment provider to one business means one thing, to another business means another thing. Remember, we have the core, supporting, generic, subdomains. So based on the context, it might be a different meanings. And based on that, I need to understand that completely that based on that terminology, I need to define the context and the boundary context of those terminologies. Again, if I am an e-commerce, I need to have integrations with a third payment provider. So the payment method for me means totally different things from a PayPal or Stripe. This way, I need to integrate and define where the payment is for me goes until where payment goes to Stripe. And based on that, we'll start to define components integration. We start to define some patterns around the communication between organizations, between domains, and so on. So you can, for example, avoid that the knowledge of Stripe goes to your domain. So you can use, for example, an anti-corruption layer. In my case, sometimes I need to have a single API to communicate with different cards. So to the client, it's just a card. For me, it may vary from Visa, MasterCard, Dynaclub, and so on. So what can I do? I can have the published language. So I need to translate Because, for example, to Visa, when the transaction finish is completed. To MasterCard is succeeded. My client does not want to care about this. So the client just wants to buy something and see the value decreasing. I mean, they don't want to see the value decreasing. You'll be amazing today to have a bug and don't decrease the value. But the point is, for the clients, they don't need to learn. They don't want to understand. So that's why we have patterns integration between components and domains. Right? So right now, hopefully you understand that the best way to start implementing domain-driven design inside the organization is starting with a strategic. And there are several ways to achieve that. So there is event storming and so on. For me, as software engineer, when I went to this organization, the most efficient way that I find out is the one thing that we as humankind has been doing for a long, long time. Telling stories, right? So probably you know about the mythology Greece, and it was invented even before the written. So this is a sample of domain storytelling where the goal is using source code. Remember, I need to keep the business close to me. And if I can convert the storytelling in code and define documentation as code, you'll be even better because I can put as Git as source of truth or GitHub. So on this case, I have my storytelling. And based on that storytelling, I can extract and convert it in static. On this case, I have my domain expert that tells domain stories to developers, that draws the domain stories, and finally, the domain expert can read and correct the domain stories. Based on that, I know where probably is my entity, where is my repositories, where is my service, based on this diagram. So for me, again, domain storytelling is the most efficient way to extract knowledge and convert to software, especially because it was designed to software engineers. So I draw this picture here, only use code. It's pretty similar to Marmed or Markdown, where you can find and you can visualize. So you can put in the version. So the branch version 001 has one storytelling, and then you can increase storytelling delivery by delivery with this information. And naturally, when we can change the domain storytelling with the new rules and then update the code. Again, it is close to the close. Probably everybody have heard or have tried at least pull the documentation in Atlassian, Jira, and so on. And eventually it gets duplicated. And the main reason is because it's far from the code. So it's far from the code is usually easier to you forget to update. So using this way, you're gonna put close to the code, you're gonna be much easier to don't keep it duplicated. So right now, we talk about strategic, how to extract knowledge using domain storytelling, and finally, we as software architect, staff engineer, can go to implement the tactic. So based on the storytelling, I can implement and define my entity where I have my unique identifier. Probably it goes to the database. I can define the service, the communication integration between my entity, repository, my collection representation, the aggregates of my entity, value object, the value that has no identity, for example, money, factories, events, and so on. So the first step, strategic, and then go to the tactic. There is this report here that comes from a philosophy of software design that shows the difference between one person that goes more to the code, focus more on the tactic to getting things done, and one software engineer who is more strategic. So as you can see, it looks like the tactical, you go faster, but in a long term, it decreases the quality faster, it decreases the speed of delivery faster, and so on. And this book also mentioned the tactical tornado. That is a person who writes code super fast. So it's impossible to compete with that person. So there is one issue. He opens, he fixes in a couple minutes, couple hours. However, it brings a consequence because it looks like a Midas in the opposite. So instead of convert the code in gold, they convert the code in shit. And right now, nobody's able to understand. And the code gives you one advice. Usually, all the team has one tactical tornado. And if there is no one came out on your mind right now, probably because it's you. So the person who focuses more on strategic knows that the software engineering goes beyond code. It's not only about code. It's about software architecture. It's about software design. It's about understanding what I need to solve. And finally, go to the code. Okay? So I talk about code, writing code. But again, I'm talking about 1,000 engineers. It's impossible to be everywhere every single time. So how can I guarantee the code, as soon I know about the strategic, keep the same quality? For me, I have 4 amazing tools that from now on is mandatory in any project that I have. The first one is ArcUnit to define the task for, how can I say, the task for software design inside my project. So I can define, for example, that my presentation layer should not be imported for my entity, for example, or my entity should not go to my controller directly, and so on. So I can define these rules. PMD is about the code quality to avoid any code issues, SQL injections, and so on. Check style is about the rules that you define inside the organization. For example, the maximum of the line size, the maximum of the method size. And finally, my favorite one is JMolecules, where you can put evidence about your software architecture decision as a notation, and then it will validate it for you. So, so if you want to start with something, JMolecules might be a good one to start. Okay, again, ArcUnit to test the architecture, PMD check style to check your code design and avoid code vulnerability. It's gonna analyze statically your code to check this kind of thing, and JMolecules to find evidence around your code decision around architecture. And of course, if you're following this. This is a sample using JMolecules. If you are using Spring, you can use those annotations, and Spring you understand. So that is one library. So I have my credit card, where is my entity. I have my ID, that is identity annotation. I won't go deeper the discussion about the perfect ID, if it should be UUID or incremented ID. But for now, just take this as sample. So I have my credit card, entity, I have my fields, my attributes, and then I have my identifier ID. So based on that, what can I do? I can, using JMolecules, I can run rules. For example, here, I have this class. It's going to analyze this package name, where I have my DDD rules, where I can run. And I can run even more architecture decisions. I can run, for example, layer architecture. I can run hexagonal model architecture. So I can validate my software architecture using JMolecules. PMD already explained. So bugs, data code, security. So if I have a huge amount of ifs, as the previous presentation said, so maybe if you are doing a lot of ifs, you are breaking the open, close, or single responsibility. So it's going to break the build if you're not following those rules. And naturally, to avoid the duplicated codes. The check style for me is more about conventions. So there are people who love space, people who love tab, but we don't need to spend and waste time discussing about that every single pull request. You define the rules, put that over organization, and right now, it doesn't matter if you agree or don't agree. If it's built, that means it goes with the organization code style. If it does not build, that means it goes against the code check style. There are several examples. In the internet, for example, Google provides this check style where you can use as inspiration. Some microsystems already has one, I guess Oracle as well. So you can see several companies' check styles where you can use and adapt to your reality on your organization. I don't recommend you to use exactly as Google because you're not Google. So there are several differences that you need to adapt. So usually Google goes more to infrastructure code, and you might need to go more to the business code. So those are the difference. As I mentioned, ArchiUnity to define the code design and code architecture. And for me, as I mentioned before, having evidence using annotation to identify where the code design is, the decisions that is taken, and so on. So to find the gap, because right now, based on just enough software architecture, we have a gap, right? Because as software architect, we talk a lot about modules. We talk about components. We talk about integrations. However, Java does not provide these as keywords, right? The exception right now is module, but you don't talk about components and integrations. So using this, you are capable to implement using annotation. So this one here comes from this book, in the inspiration. It is worth to try to take a look. Naturally, when talk about software architecture, I know a lot of people has your own opinion about software architecture. Trust me, I work as a software engineer, but I'm a person who goes to the academy, study, and write books. And if you go to every single definition of software architecture here, you might see different meanings. So to everybody, software architecture might be a different meaning. However, those have a common goal, that is be close to the client. So if you are a software architect in your organization, it is time to get close to the business. It is time to be there. It's time to help and define the methodology to transfer knowledge inside the organization, right? Mainly because when talk about software architecture, doesn't matter the book. They usually have two rules. The rule number one, everything is about trade-off. Java is amazing, yes, but there is something that's not work very well. Nobody knows where or what, but trust me, eventually we're gonna find out. And naturally, the why, the reason to write code is more important than how. So it doesn't matter if I write a beautiful Java code, but if it's not achieving what the client wants, it's become a waste of time, a waste of money, and so on. So, and every time that we talk about software architecture, we naturally need to talk about software design, because there is this amazing book, Head First Software Architecture, and for me, the best definition ever that I have seen, where he explained that software architecture, software design is about spectrum. So eventually, when you do software architecture, you will impact the software design. And when you do a lot of software design, we will impact the software architect. So the main point here is how to balance and understand how to make everybody going to the right direction. So naturally, I know everybody hates, but unfortunately, it's necessary documentation. For me, when I become software architect, my first thought will be, okay, the most difficult thing will be to create a scalable application. But that is the most easiest thing in my career. The hardest thing is make people scalable. And the documentation is one way to achieve that. So write a README, write changelog, make a clear documentation, use JavaDoc if it does make sense, write open API documentation. Just make sure that everybody knows about the repository. Just look into the README project. People knows about what's going on in the next version, just checking the change log. And again, tactical, strategic, go to architecture decisions, so the integrations, the reasons. So if you're an architect, it is time to write in a C4 model, define the tech radar, so I will put that as optional one. Define architecture decision records. It's about to measure by trade-offs. So it is time to say goodbye. I'm gonna use Java because it's cool. It is time to become more an architect to define why you're using Java based on trade-offs. And finally, a clear communication. So I know that we hate documentation, but we hate even more another thing: meetings. Remember that. So every time that we write more documentation, that means less meetings. And trust me, my first 6 months as software architect, I spent like 5-6 hours every day doing meetings. And it was super fun because when I started asking about the project code, the reason, and the people said, okay, I am the documentation. And then, man, sorry, but I'm not Jedi. I don't have mind powers. How can I do right now? So we spend a lot of time writing documentation, trusting the knowledge to the as documentation. And right now, our onboard takes 2 weeks. To a bank with over 20,000 engineers, it is a good number, just 2 weeks. Just because documentation, and right now I have 30 minutes meetings every day. So I decreased a lot because documentation is as asynchronous. So every time that somebody asks me something, I show the line of documentation. Go for that. Go for that. And if somebody invites me to a meeting where there is no descriptions, no reason, by default, I say no. Even my boss, but how can I say? Okay, documentation is important. Architecture styles, hopefully you understand my point. It's super important, but remember, the right patterns in the wrong context means a non-pattern. So there is a huge word beyond microservice and hexagonal model. I know my senior engineers only talks about clean architecture book. It is amazing. I'm not complaining about this book, but trust me, there is a huge universe beyond this book. There is a huge universe beyond this pattern. So you can explore much more these architecture styles if you understand that I can implement microservice when it does make sense. I can use monolith. Monolith is not deprecated. Okay, so you can use modules with monoliths. You can do a distributed monolith and so on. So you can define layers to your monolith. It's not a crime using the right tool in the right time in the right context. Domain-driven design is about layers. So the book definition by Eric Evans, he explained about the aggregation and separation. So the presentations, the applications, the domain, and infrastructure. And naturally, if you really need to use hexagonal model, go for it, because domain-driven design fits perfectly with hexagonal model, clean architecture stuff. So you can go to buzzwords and also implement domain-driven design at the same time. And naturally, so after that, read the documentation, make sure everybody goes the same direction, understand the strategic point. It is time to talk about making the code evolutionary. So I talk about documentation that everybody hates. Okay, it's time, please stay. I'm gonna say another word, that is test. But you hate something even more than test. That is spending weekend working because a bug, right? So if you write tests, you can increase your reliability doing that. You can reduce the complexity. And mainly, when we decide to increase features, capabilities, you become way easier if you go to this way. So right now we have some metrics inside my organization, and usually right now we decrease around 30-35% of the answer of bugs because we have tasks and we have procedure. So every new bug must be a new test. This way I can avoid regression. So I change something and then bring another thing, like a Hydra, right? So the goal is to avoid this kind of thing with tests. And naturally, over 1 decade of code, it's time to move and keep the code moving with the legacy modernization. And your code must be ready for change. It's part of the business, right? So I will usually work in the bank and finance area, and then I go to several projects that was running at that time Java 5, and the people said, no, it's Java time. But if you check the history, design patterns is even before Java. Sometimes there's no excuse to write a not good code. Of course, the Java syntax increased the reliability, yes. The Java syntax helps, yes. But design patterns is even before Java. So you can write a good code even with or without this new syntax sugar and these things that's wonderful, by the way. So our goal as software architect, as senior engineer, is fighting the complexity inside the organization. So if you check out for any book focused on seniors and architects, you can see that. So everybody's talking about complexity, especially because when you talk about complexity over hundreds of engineers, it's become a nightmare. So complexity is one thing that's hard to understand. This book, A Philosophy of Design, brings 3 measurements to identify the complexity. The one is the change amplification. So I need to create a new capability inside my software. How much layers do I need to change to achieve that? 1, 2, 3, 10, 15. So as much components, that means more complex. Cognitive load, how much days I need to take to do onboard in one person. Days, weeks, months. And naturally, what everybody knows, the unknowns. So things that you're going to see only on production when some things crash. And there is no way to prevent that. So I did a lot of integrations, third-party integrations. We test a lot on homologation. And when it goes to productions, nightmare. So cognitive load, change amplification, and what you cannot control, that is the unknowns. That is it for today. So scalability goes much beyond application. If you are a software architect or want to become one, that is on reality the easiest part. Guarantee culture, methodology, and quality is way harder. And naturally, when talk about communication over large organizations, the communication has a huge amount of silos of knowledge. The lack of leadership, we could see, for example, a lot of people with the flat organization structure that, by the way, I never seen it working on reality. It's super beautiful to say that nobody is an architect, but I never see that working properly. Fragile architectures, because everybody decides, everybody votes, and one person with 1 year experience had the same vote of a software architecture of 10 years. So naturally, something goes wrong. And as I mentioned before, the Scrum become like a failure or waterfall pipelines. So domain-driven design using Agile can enable the tech leadership, can increase the software architecture. It can help with optimizations and break the communication silos, mainly about the communication. And one tip that I give to you if you want to apply that today or tomorrow inside your organization is only 5 steps. The first one is find a person who is capable to become a staff engineer or software architect or wants to become one. Then make this person part of the team. So, and when I mean team, I mean the business team. So this person should know about the business way more than everybody else, the average. Then naturally documentations to make sure that everybody goes to the same directions. Optimizations, like I mentioned in governance of software architecture. So put in tests, what makes sense, Arc Unity, J molecules, when it makes sense, and then the feedback loop to check if everything's okay and how to improve. And I mentioned about topics, and the main goal today is when talk about domain-driven design, the context is the king. The right pattern in the wrong context become an anti-pattern. So it doesn't matter if you write a good documentation, persistence, code design, software architecture, leadership, and tests, if you are not doing properly based on the context. To help with that, I wrote a book. So that is this QR code where you can check. It is the Ultimate Engineer. So for me, is a step-by-step how to understand the enhancement of code design, understand more about what is software architecture, soft design, persistence, tests, and so on. So you can understand more about how to become a Ultimate Engineer. And that is it for today. So my name is Otavio Santana, software engineer and architect, Java champion, Oracle ACE director. I have been working Java as executive member since Java 8. So if you have enjoyed Java, you're welcome. If not, please don't kill me. I'm doing my best to make Java even greater every single version. I know that a lot of people hate because right now I have a new version every 6 months. Try to don't kill me because of that. Beyond being executive member of the JCP in Java, I'm also part of Apache Eclipse committer as Jakarta E spec lead in several specification mainly and the persistency. And based on that, as you can see, I don't have social life. I write articles, blogs, and so on. And I received some JCP award, Duke Choice Award, and I wrote a lot of books about software engineers. So that is it for today. Thank you.